number of steps that frequently involves, and this is another important piece of information about the definition of algorithm, that frequently involves repetition of an operation. Broadly speaking, it's a step-by-step procedure for solving a problem or accomplishing some end. So, the first definition is that we are facing with some mathematical problem. It must be composed of a finite number of steps. This is another very important ingredient, and frequently, not always, but frequently, we have some kind of repetitions. We'll see some proper and improper examples of algorithms. For example, preparing your favorite tea, a cup of tea, implies an algorithm. It's an algorithm you already know from your childhood. Nobody actually taught you how to prepare a cup of tea, but you learned by seeing. In any case, you know that there is a precise number of steps. And of course, I'm not referring to the ceremony of tea as in Japan usually done, but I mean, preparing a cup of tea requires an algorithm. Finding the right key to opening an unknown lock requires the application of another algorithm. This is the case, for example, suppose you are given a bunch of keys, of unknown keys, and you have to open a locked unknown door. So it's not your home door, you already know the key, you already know the lock, and so on. You are given an unknown bunch of keys, and you have to open a locked door. What do you do? The only way to solving this problem is to try to insert the first key, trying to rotate. If it enters, you try to rotate. Otherwise, you skip to the next key, try to insert. If so, try to rotate. If it happens, you try to unlock. Otherwise, you skip to the next key, and so on. In this simple case, you are facing you are applying an algorithm in which there is a repetition, in which you try to insert a key. No, every key fits in every lock. Okay, because of orientation, because of form, because of shape, and so on. If it fits, you try to rotate. Even if the key fits into the lock, it not always rotates. Okay, so these are, you all know how to open a door, of course. You are applying an algorithm. Another definition provided by one of the geniuses of computer science, Donald Knuth, who is currently in his 80s, but is still active. It's a brilliant mind, actually a brilliant mind, author of a kind of seminal collection of books known as The Art of Computer Programming, who paved the way for algorithms, computer programming, computer architecture, and so on, defined an algorithm as a finite, definite, effective procedure with some input and some output. In the case of the door, the input is the bunch of keys, the output is opening or not opening the door. And the point, of course, we have no, there is no way to know in advance if an algorithm will conclude with a positive outcome. You may open or not your key, you may find or not a name, a contact in your phone book, and so on. Okay, okay.
Giacomo, scusa, ci sono dei ragazzi che stanno entrando, va bene?
Certo. The first row is empty, so 3 of you may fit. So 1, 2, 3, 4. 1, okay. You. Come on. 3.
We try to stay this time for the moment.
Okay. Two may fit upstairs. And one, sir, sit down here.
Giacomo, se puoi fare una sessione con questi ragazzi per l'app, tu questi non ce l'avevano.
Non ho capito.
Per l'utilizzo dell'app, magari qualcuno di loro ve lo spiega.
Quale app?
Quella per entrare dentro.
No, non sono preparato.
Ok, vabbè. I ragazzi, io mando dalla guida, digli di cliccare sulla guida, perché loro devono fare i booking della stanza.
Ah, ok.
E quando ti fanno il booking esce il cuore conto.
Io gliel'avevo scritto, view booking, perché avevo sentito, mi ricordo che tu avevi accennato.
Ti ricordi quei 5 step?
Sì.
Li devono leggere, perché devono avere il documento addosso in inglese, qualcuno ce l'aveva, riempito, e gliel'avevo lasciato alle guardie, e poi non li fanno entrare senza cuore conto.
Ok, ok.
Guys, tomorrow, no QR code, no answer. Okay? Who did it? Who has the QR code? You tried? Please. Can you explain during the break or after the last lecture how we use it, please? Can I ask you within us?
I have actually scanned it in the group.
Very well, great. Please, tomorrow with QR code. No QR code, no answer. Okay? Because there is a common revelation. Please, try to understand it. Okay? Okay. Thank you. Apologize for the interruption.
No problem. You're welcome.
Bye-bye.
So please, what are the newcomers? Your name?
Ashik. Ashik.
Okay, and you are from?
I'm from India.
Okay, welcome.
My name is Tarun.
Your name is?
Tarun.
And you are from?
India.
Okay.
Uday. From India.
Okay.
Yeah.
Oh, baby. And then you?
I'm Ramesh from India. I'm Ramesh from India. Srishant from India. I'm Siddhivinayak from India.
Okay, all Indian. Okay, welcome. Any other? Did I miss someone? No. Okay, welcome. Okay, let's go on. What does algorithm come? Where does algorithm come? The term, the name algorithm come from? It comes from. The meaning is algorithm is a procedure with Arabian numbers, and there are some. There is a wrong etymology. Speaking about algiros, which is a Greek, which is an old Greek term meaning pain, painful, and arithmos, number. But it meaning that kind of algorithms deal with pain and numbers, painful numbers. But it's not true. Trust me. Actually, the name is a kind of more mythical because it goes back to a region of Central Asia called Khorasan, which was the birthplace of one of the most famous Persian mathematicians, Abu Abd Allah Muhammad ibn Musa al-Khwarizm, which is the town, which is the region from which he came from. He was the author of a famous book, a famous text known as Kitab al-Jabr wal-Muqabala, which contains, if you look carefully, which contains one of the most important words in mathematics. Any guess? Look at the name of the book, and even if it's an Arabian name, it contains a fundamental word in mathematics. Sorry? No. Algebra, which is the stem for algebra. Okay, algebra comes from algebra, and even Muqabala is a name coming from which resembles the Hebrew Kabbalah, which is a part of their religious textbooks dealing with numbers. But okay, let's go on. This is a picture of taken from a stamp actually, and this is the region Khorasan. Okay, in this region, it was, and this is where it can. Okay, why is necessary to study algorithms? There are some applications. First of all, internet, searching, packet routing, file sharing, distribution, and so on. Biology, protein folding. Proteins are large molecules, and which are composed starting from amino acids, which are smaller molecules. The combination of amino acids gives place to proteins, which are very fundamental in life. And the idea is that a protein can fold and unfold. It's active when, because some active sites in this kind of strange surface become available to other molecules, large molecules. Okay, of course, there is a lot of algorithms dealing with genomes, human and other species genome. Of course, informatics, circuit design, databases, networking, compilers, and so on. Computer graphics, of course. Security, refer to smartphones, e-commerce, financial transactions, and so on. Social networks, news feeds. You know, in a given moment of our day, an enormous amount of news is produced and broadcasted. Nevertheless, we receive only a tiny amount of news. And the reason is that only news that are thought as important, that are regarded as important for us, are vehiculated to us. only those that some algorithms. I'm using an impersonal exception, but this is a recommendation. If you give a look at your favorite social network, you will find that you are continuously suggested of new friends, of new people to follow. This people is the output of some algorithms which find the most similar users according to your tastes, according to your political views, according to your religion, according to your favorite sport and music, and so on. So if you are fond of chess, you will probably be suggested of a number of other chess players, chess news, and so on. If you are fond of some singer, you will be, and so on. So there is of course, these algorithms are much more refined than what I am simply speaking about, because they cross information coming from different environments, from different contexts. For example, they will suggest you someone who is fond of the same singer and of the same football team and of the same political views and so on. So the kind of sophisticated intersections of different contexts. Of course, there is here I only mentioned physics, but algorithms can be found in almost every realm of science. Physics, biology, archaeology. There is a brand new field in archaeology dealing with views from satellite and trying to devise how archaeological sites can be found. You see something that it appears as a photo with only green spots, okay, but below this wall of green from the satellite, there is a town. There is an ancient town, okay. And applying the correct algorithms, it's possible to figure out where is the town. This is just an example. Of course, n-body systems simulations. Think, for example, to your favorite game in which there are objects falling, they must follow physics law. I mean, there is a lot of applications. Algorithms heavily rely on data structures. Which answer the following question: which is the best way to arrange some pieces of information? For example, a set of numbers. Depending on the problem you are tackling, you may have different solutions. Probably the simplest way to solve the problem of arranging some numbers is to use an array, in which this is the case of a C-like array indexing. You have a set of indices, each indicating the position of the array we are working with. So the first location will be 0, the second will be 1, and so on. which is the simplest. In some situations, an array is not enough. This is the case, for example, of a queue, in which you have not only to store people in queued, for example, at a bank office, but you have also to store their arrival time. Okay, so this guy arrived earlier than this one. Okay, and so on. Of course, given these fences, it's quite improbable that someone traverses the queue and will be served earlier than the first one. But the idea is this one. In some, there is some other situations. For example, this is a stack. This is a stack of dishes, and usually you never take the lowest one in the stack. If you arrange the dishes as a stack, you will place the topmost, and you will take the topmost. Okay, so this is a different philosophy with respect to the queue. In the queue, the first in is the first out. Hopefully, if nobody changes the arrival time, the priority. Okay. In a stack, the philosophy is the last in, the last dish you add to the stack will be the first you take. So last in, first out, LIFO philosophy. So far, we have seen three introductory, very brutal, very simple examples of linear structures. I have the first, the second, the third, the fourth, and so on. But we may have, in some situations, we need to create better okay. But in some situations, you need better data arrangement. Suppose, for example, you have your own phone book on your smartphone. Very well. In this case, you have a list. You may see kind of array in which you use to store your contacts. But what if you need a kind of alphabetic ordering? You should rearrange continuously your phone book upon a relation of contacts. To avoid this problem, it's better to use a smart linear arrangement, which is named linked list. This is a simply linked list because there is only one pointer from. Sorry.
Hello.
Okay, here. Okay. Sorry, here we are. Okay, so which is the idea behind the linked lists? The idea is that we have a kind of linear arrangement, but because of pointers represented by the arrows, there is the possibility to modify this linear arrangement. As in the case of, suppose you want to delete node with value 99. If you were using an array, you should remove the element with value 99, and then you should displace, you should shift on the leftward, all the elements lying on the right of node 99. Okay, which of course requires some computation, which of course requires some time, which of course requires some money. Instead, if we adopt a linked list, we may update this arrow to point to the node with value 37, and therefore skip node 99, which can eventually be dropped from the list. Is it clear? Of course, the same philosophy lies behind the insertion of a new element. Suppose you need to insert a name which goes between two nodes. You simply have to update this pointer to point to reference to refer to the new element, and so on. Okay, this is a kind of linear but not so strictly linear arrangement of elements. The step beyond implies a non-linear arrangement. This is the case, these data structures are known as trees in computer science. And, you know, computer scientists draw trees upward. So the root is the topmost element and the leaves are the lowermost. the other way. And the idea is why do we adopt a tree? And the answer is that this way we may create links between, depending on the nature of the tree, but this is a binary tree because each node may have two children, two children nodes from 0 to 2. 0 is the minimum, 2 is the maximum value of the maximum number of children. You may establish a relation between more nodes than with a linear arrangement. In a linked list, you have a link. In this simple case, you have only one pointer linking node 12 to 19 and node 19 to 37 and so on. If you have a more refined, a more sophisticated linked list, which goes under the name of doubly linked list, you will have two arrows. One linking to the previous element and one linking to the following, to the next element. Okay? So, in the doubly linked list, you have two links. But what if you need more links with other elements? In this case, you must overcome the linear, you must abandon the linear arrangement and adopt, for example, the tree arrangement, according to which you may have, for example, that node 2 has links with 3 and 6. 3 has links not only with 2, but also with 8 and 10. So look, this median node has 3 links, not only 2 as in the linked list. Okay? Applications of the trees. They are used usually, for example, for searching, which, if you focus, is the kind of search you adopt when you are using a dictionary. When you use a dictionary, you never begin from the first page and span all the pages until the last one. You open it in the middle, and depending on what you are searching, if you are searching for a word that lies in the first half, you focus on the first and abandon, ideally abandon the second half. If your word lies, you abandon the first half and you. So what happens is that you open your dictionary in the middle. Depending on which part you are interested in, you focus on that part, and you open it in the middle, and you open it in the middle, and so on. So you progressively reduce the interval in which your word lies until you find it. Actually, you are using an ideal tree in which you divide every level, every time you open your dictionary, you divide it into two halves. The first one is abandoned, the second one is used, and so on. Something similar can be done, for example, when you want to arrange some numbers, and you want to find if you have a set of numbers, and you want to find if a number is contained in that sequence or not. For example, is number 13 contained in this sequence? If we arrange our set of numbers in a linear sequence, we should examine one by one, starting from the beginning. If we arrange our set of numbers as a binary search tree, what happens is that this is not the case, okay? What happens is that the root node will contain a kind of median element in your sequence. All nodes on the left subtree will contain numbers smaller than that contained in the root, and the numbers contained in the right subtree, so this one, will contain numbers greater than the root. So suppose you are searching for 13. What you have to do is to compare 13 with the root node. If your numbers is larger than the root, you will focus on the right subtree. Otherwise, you will focus on the left subtree, and so on, until you get the number. Of course, this is just an introduction, and we'll please, sir, come in. 1, 2, no. 1, 2, 3. No upstairs. Okay, down here. Okay. No. Okay, upstairs and still upstairs. I guess. No. Only available places. Okay. Welcome. Your name and you are from? You are? And you are from?
I'm Vinay. I'm from India. From India.
Okay. If we decide that 3 links are not enough if in our problem 3 links, for example, are not enough and we need more of them, then the trees are not our ideal choice, and we must adopt an even more refined data structure, which goes under the name of graph. This is a graph in which every node has possibly a link with all other nodes in the graph. This is the mathematical structure that best describes relations existing in any guess? Social networks, of course, in which possibly a user could be in principle in contact with all other with all other nodes. Is there anyone outside? No. Okay, so when dealing with graphs, we have no limit as to the number of links each node may have. So one link in simply linked list, two links in doubly linked list, three links in binary trees, an infinite number of links in graphs. So this is the steps, this is the ideal steps that compose our structure and our study when dealing with data structures. So we'll begin from the simplest one and go up to graphs. What do we study? Sorry. Any question from the online students? Is there anyone out there? Hello? Sorry? Okay, so what do we study in algorithms and data structures? Of course, we study algorithms. Of course, we study data structures. Is this a clever answer? Not so clever. Okay, it's kind of find X, here it is. Okay, so not very clever. Okay, of course, seriously, what do we study? We'll begin with some basic concepts of Python programming. We'll begin working with Python, as Python will be our our only and favorite language for algorithms, for data structures, and so on. The idea is that you know, if you pick at random an algorithm textbook, famous, for example, algorithms textbooks, such there's some of them well known, you will find that algorithms are described in a kind of meta language, which is not a proper programming language, but it's not completely a natural language. So it's a kind of bridge between natural language and poor programming language. Of course, I think it's useful, of course, but I think that adopting a pure programming language can help us in better understanding, better implementing our algorithms. And this is why we first study Python, then we will use Python to implement data structures and algorithms. This means that we'll first learn the basics of Python, and then, for example, we will be able to implement, to code a graph using Python, to code a sorting algorithm using Python, and so on. This is our goal. Then we'll study fundamental algorithms, for example, sorting algorithms, but not only, searching, for example, and fundamental data structures, meaning arrays, lists, stacks, here a key is missing, sorry, queues, trees, graphs, and so on. And we'll also carry out an analysis of the quality of algorithms. Because, you know, you may devise any sorting algorithm, but you should compare the quality of your algorithm with respect to the existing algorithms? Yes. Gentlemen, sorry? 2-4. Just a moment. Of course, people is always welcome in class. Only allowed seats should be used. Sorry. So yes, that one. My suggestion is because of the position of this board. My suggestion is to use first the seats and then these ones. Don't sit. Okay, so. Any questions? Yes? Sorry? Is it possible? Do you know how to write it? You have no idea. I'm sorry.
Just make this slide larger.
Sorry?
Make this slide larger.
Yes, but the point is that if I set the full screen, I miss this list with the right answer. This is the idea. But probably I should be able to alert. This one. Better? Better? Okay, so this is okay, our activities. Oh, first of all, welcome to our new students. Your name and and where are you from? You are from? Okay, welcome. And you are? From Rwanda as well? From Pakistan. Okay, welcome. Our activities, blended lectures, until this epidemic will last, we will have to carry out blended lectures. Our timetable is this one, 9 to 11 on Monday, Tuesday, Wednesday, and Thursday, and 11 to 13 on Friday. So every morning we have lectures. Strongly suggested attendance. Let me put as clear as possible. Strongly suggested active attendance. No people sleeping in the class. So active students willing to study, willing to learn, willing to improve their knowledge and so on. Attendance is nearly mandatory. Please do not come the first lecture, then miss 2 or 3 or 4, then come next week, then come next week, and so on. It's a waste of time, it's a waste of energy, it's a waste of everything. Come every day, every morning, attend the lecture, raise your hand whenever something is obscure. Be an active student. This is the first and fundamental ingredient for the quality of these lectures. Okay? Of course, study is necessary. Okay, something about exams. Actually, God knows this could be the only content of this slide. Nobody knows. If possible, the idea is to have written exam plus oral exam elective. We hope, at least. If not, if we should we switch to only online activities, so lectures and exams, of course, only oral exams. The exam dates can be found on S3. You should have a university account. Yes? Okay. Then you should use it to enter S3 and find out the okay, and this is for books. In red, the fundamental books, whereas the blue ones are less fundamental, are suggested, are very useful, but they are not fundamental. Okay, first of all, Allen Downey, Think Python, second version 2.4.0, this is the one I found. This is freely available. The publisher is Green Tea Press, and it's freely downloadable. You can freely download from the web. Whereas this one, Python for Everyone, Horstman and Nikkei, is a very good book, but it's not free of charge, of course. The combination of these two books entirely covers the topics Python programming. And then, of course, these are very good books on Python, but they are not introductory, whereas especially this one can be of great help in beginning Python. Okay, and now as to algorithms, the book we rely on is this one, Corman, Laserson, Rivers, Stein, Introduction to Algorithms and Data Structures. Third edition, even if you find the second is good enough. I mean, there is no such difference between subsequent editions. This is probably the best textbook on algorithms worldwide. Not because I suggest it, but the other way. I suggest it because it's the best one. It's adopted in the best universities all over the world. So it's a great book. There is also another very interesting book, which is very far from the level, from the quality level of the Corman, which is the Goodrich, Tamassia, Goldwasser, Data Structures and Algorithms in Python. The great advantage of this book, from my point of view, is that it adopts Python to describe almost all algorithms, not all algorithms, but a good percentage of algorithms. But don't worry, our activity will be of studying every algorithm one by one and discussing, introducing, and so on. So there will be no problem. Educational material, books, of course, reviews. Will do a lot of practical activity in during classes, and all the written exam papers, but this is in progress because they are in Italian, and this could be a problem for most of you. Educational material will be shared on Moodle and Teams pages of the course. Okay, so you can download from it. Any question?
He says that where we can find books.
Okay, the free one can be downloaded from the web. If you Google Think Python second edition, you can download it. The other ones are not free. But if you search kind of libgen or some unofficial and illegal downloading, you can find it. Okay. As to contacts, feel free to email me for any questions, for any discussion, and so on. I will answer as soon as possible, meaning that, of course, while I am lecturing, I cannot answer emails, of course. So don't flood me with your emails. Why don't you answer? Why don't you answer? Why don't you answer? It may happen. I'm currently have to read 6 graduation theses. So, for example, in these days, I'm pretty busy. When you write to me using email, use only the university email account, which should be kind of at studenti.unime.it. Do not use other emails, because identity is not officially official, as if from university email. I cannot give you some kind of confidential information. Okay, so I use only the university email. Most importantly, as of yesterday night, you were kind of 139 students. So communications will be issued, will be broadcasted using, for example, your official emails, Teams chat, and so on. So give a look at your emails, give a look at your Teams account, and so on, for communication. Any question? Online students, any question?
No.
Okay, at least there is someone outside out there. Okay, I would like to Ibek Erkinbeck, would you like to switch your camera on and introduce yourself? Ibek, where are you? Are you sleeping? Come to Dang. Are you there? Not precisely. They are only going away. Dean Yeo Wong, are you there?
Yeah.
Okay, would you like to switch on your camera and introduce yourself? Yes. Okay. We saw again at the beginning. Okay. Thank you. Sorry. I learn your names. Hassan Saed. Are you there?
Yes, sir.
Would you like to switch on your camera?
Well, yes, sir. Why not?
Yes. Oh,
Hello,
there is a
sir.
crowd. There is a crowd of people. No, are you there? Okay.
Yes, sir.
Welcome. Where are you from?
Thank.
Sorry.
I'm from Pakistan. I'm from
Okay.
Pakistan.
Welcome. Welcome.
Thank you, sir.
Jainam Aresh Kumar Prajapati.
Yes, sir. Hi,
Are you
sir. Good
there?
morning.
Would you like
Yes,
to
sir.
introduce yourself?
Yes, sir. Sure. My name is Jainam. I'm from India.
Okay.
Can you
Welcome.
yeah.
Yes, yes,
Thank you,
yes.
sir.
Are you in
Thank you.
Messina?
No, I'm in India currently.
Okay. Okay. So you
Yes.
are you are Pakistani, but you live in India?
No, I'm Indian. I'm Indian.
Oh, okay. Sorry.
No
Sorry.
worries, sir.
Well, I mean, I'm not joking. Usually, seriously, I'm not joking. I never joke with students. I was just crowded with a lot of nationalities.
Yes, sir. No problem.
Thank you, and
Thanks.
my apologies.
No problem.
Muhammad Ibrahim Khan Lodi, are you there?
Yes. Yes.
Would you like to introduce yourself?
I'm Ibrahim. I'm from Pakistan.
Where are you? Okay, welcome. Thank you very much. Welcome on board. Muhammad Shahmer Khan, are you there?
Yes, sir. How are you, sir?
I'm fine, thanks. And you?
I'm also good.
Where are you? Where are you
I'm
from?
in Rome. I'm from Pakistan.
Okay. Welcome.
Thanks.
Ruslan Skivka,
I'm
are you
here,
there?
Yes, buongiorno professore, scusate, sono sbagliato la gruppa perché pensavo che lei segue lezioni come l'anno precedente italiano.
Ah, no.
Sì, ce l'avevo.
Nessun problema.
Scusate, ora seguo vostra lezione, però domani collego l'altro professore perché ho visto che lui segue italiano. Grazie.
Sì. Ok, arrivederci. Terlokan, are you there?
Yeah. Yes, sir. Hello, sir. I am Tarlochan and I am from Pakistan.
Would you like to switch on your camera?
Yes, sir. Why not?
Okay, welcome.
Well, thank you, sir. Have a nice day.
Welcome, all the best. Did I interview Tin Lan and Trin?
Hello, Professor. Hi, everyone.
Good morning. Oh yes, I already saw you. Okay, thank you.
Good morning.
Good morning. Any question about the?
No.
Okay, very well. Tuan Man Nguyen. Oh, okay, we already. Okay, very well. May I ask why people leaves and then goes back? Yes. All of them at the same moment while I am interviewing them. My opinion is that this epidemic originated some tactics how to manage online activities. So kind of, poor connection, or while I'm streaming a Netflix movie, or I cannot hear you. Can you repeat my question while I compose my book and figure out how to answer and so on? I mean, there's a kind of, but of course. This is a good question. I'm not sure about recording lectures because this is a kind invitation for online students to sleep during lectures because of the early hour and so on. So I have to decide. Sorry? Can you promise to study on the books only? I mean, this is the main issue about slides sharing. I always shared my slides. I mean, they are thought not for me. They are thought for lectures and students to be an help in not studying, because you cannot study an exam on slides. They are enough. Okay, look, this is a hot topic and I must focus and must study well this topic. This one has not been, this is how he spoke about this topic and so on. This is the idea of slides. But if students only use slides to study, it's a poor thing. So I'm not sure about this. Okay, so let's begin with okay. The first, we begin speaking about, we devote this last half an hour to speaking about Python. Python is a relatively new programming language, and you can and you have to download free of charge from the web. It's currently the 3.8 or 3.9 version, major version, and it's quite easy to download and install on your PC. Do you have a laptop? How many of you? Okay, okay, thank you. Very well. So my suggestion is to install as soon as possible, and as soon as possible means now, today, or even now, and this is an old, or even better, you may download and install Anaconda, which is the point is the following. You may adopt a kind of this kind of platform.
Hi, sir. I'm not getting what you are saying, sir.
Do you see the screen? I'm sharing my screen. Hassan? Yeah, currently under the Wi-Fi.
I'm searching for Wi-Fi.
There is a Unime Wi-Fi. University account. Yes? Yes, of course. Sorry?
I asked that anytime about without asking.
Sorry, your mask really contours
Okay, no problem.
your voice.
I said each time you need to ask to go to the bathroom or just you can go.
Oh, I mean, my ideal class doesn't go to bathroom, of course. But I know that there are physiological limits, of course, so there is no need to ask for permission, provided it's a physiological number of times. So go to the bathroom whenever you need, but no more than one time in a term. You're welcome. I'm talking. Does it have a tiny screwdriver for my glasses? Yes, very, very tiny. I don't know. This is what happened. But they understood.
No, I don't know.
Okay.
I will bring it tomorrow.
Now tomorrow is too late. We go to the official immediately after, shortly after the lecture. Thank you. Any others? Okay. Do you see the board? Okay. This is a Python environment, productive environment, known as Jupiter. It's a kind of Jupiter plus Py, which is the beginning part of the initial part of the Python word. So it's used almost everywhere in Python environments, Python modules, Python libraries, and so on. And probably most people doesn't listen to me. Okay. And this can be used for our coding purposes. For example, print welcome, and then run, and this is the result. Okay, so this is, of course, you may so you may insert longer fragments of code. Your program is divided into cells. It's called a notebook. This is the first cell, this is the second cell, and so on. You may insert the new cells, you may delete unnecessary ones, and so on. And okay, this is a solution. Well, if you like this kind of environments, you should download Anaconda. Anaconda can be found in two different versions, 2 and 3. Use edition 3, version 3, because as to Python there is a strange situation. Kind of more or less 10 years ago, Python 3 was released, and as it commonly happens in all programming languages, all software versions, and so on, if you release version 3, you abandon development of previous older versions. This never happened with Python 2, which was developed until some months ago. So there were two parallel versions, Python 2 and Python 3. Now, finally, after kind of 10 years, Python 2 was finally abandoned. No more updates, no more new subversions. So it will finally end, and only will be left with only Python 3. So don't waste your time. By the way, there are very small differences between Python 2 and Python 3 families of versions, but there is no need to waste your time with an old version that never will be used in the next future. So adopt Python 3 and use it. There is no difficulty. It's not more complex than Python 3. It's precisely the same level, but it's newer. It's designed, has been designed in a better way, and so use it. Okay, if you download Anaconda and install on your laptop, you will find that it already contains a Python interpreter which you can use from the very moment you start your Jupyter notebook. Okay, so the idea is that otherwise, if you may adopt another. You may adopt, for example, this is an exercise I was carrying out some days ago. This is another way of working. I have a traditional text editor which I use for writing LaTeX documents, for writing text documents, for reading text documents, for writing Python codes. So this is a traditional text editor. You may write your code in using any text editor, and then you execute it, and you have, of course, the same results. So it's up to you. You may download Anaconda 3 or Python 3. There is no problem. It's up to you. Adopt it and use it as soon as possible. So today. Okay. Any question?
Hello, excuse me, sir. I have a question.
Yes, go on.
Yes, sir. Which application you will use more, like Python or Anaconda?
Sorry? Which application?
Yes, you will use more Python or Anaconda to teach us?
My guess is that in my past experience, Jupyter proved more user-friendly and more readable and easily shareable. So in past courses, I downloaded a Python file and shared with students at the end of the lecture. So probably, but I mean, I can obtain the same. I can do the same with any other programming. So it's up to you. If you prefer a kind of similar web-based environment, adopt Jupyter. Otherwise, you may simply download Python. Okay?
Okay, thank you, sir.
Yeah, you are welcome. Any other? Okay. This is an example of a minimal notebook. This is the alternative. Let me show you. This is. Can you? Okay. Do you see? Upstairs. Okay, I'm using a Linux box, so I invoke the Python interpreter using interface terminal. I type Python. My installation is the Python 3.8, which is not very old because I installed 1-2 months ago. It comes with the Anaconda bundle, with the Anaconda installation, and you will see that these 3 signs represent the prompt of the Python interpreter, which means that the system is ready to accept my commands, which can be as easy as this one, or for I in range 10, Oh, I forgot. This is a problem with this command line interface. Okay. Actually, there are three different environments you may use when if you need to work with Python. Command line interface, which is the worst, by the way. Using a text editor, a kind of IDE, you may there is plenty of this. For example, Atom, ATOM is one of them. PyCharm, PyCharm is another one. Spider, SPYDER is another one. These are the most famous, the very widespread Python IDEs. You can adopt one of them. It's up to you. Or you may use the Anaconda plus Jupyter. But remember that if you save your Python program in when using Jupyter, it will save it as not as a .py, which is the conventional extension of your Python programs. Rather, it uses by default IPyMB, Interactive Python Notebook format, which actually consists in a JSON file. So it's a text file, but it has a very different format. It cannot be read. If you need, for example, to send a review to my email or my Teams chat account, you have first to download your Jupyter notebook as a Python program and then send to me. Okay? It's clear for everyone? Okay. Okay. This is the very first Python set of instructions. The very beginning. What about programming exam? How many of you took this exam? One? Okay. How many of you studied this course? Okay. Okay. How many know what a variable is in any programming language? Please.
A variable is in which we can define value.
Okay.
There are different types of variables like int, float.
Okay. So what happens is that when our program carries out a computation, any kind of computation, we need to store some values, which can be input values or intermediate values, which our program produces during computations, or output values, which is the final output we need from our computer, from our program. Therefore, we use Therefore, our program needs some places in which these pieces of information need to be stored. These places are called variables. Variables, of course, because their content can be modified depending on our needs. So if we need to change what is stored in a variable, we may modify, so can vary. How to create new variables? The simplest way is to assign a value. So an assignment instruction allows to create a new variable specifying its name and assigning a value. For example, hello world assigned to the variable msg is an instruction, is a Python instruction, and is assignment. The most fundamental concept you need to understand from this instruction is that the equality sign, the equality symbol, is not intended in the mathematical meaning. So the equality is not as in mathematics, in which a quantity on the left-hand side is the same as the quantity on the left-hand side, which is the meaning of equality. What's on the left is equal to what's on the right. This is not the case in computer science, in programming languages. Rather, the meaning is take what's on the right and store in the location, in the memory location, in the variable on the left. Okay, that's the meaning. Okay, and this is so in your mind, please every time replace the equality with the left arrow. So what's on the right must be stored on the left. And think of assignments as instructions in which we declare, we create a new name to specify a memory location. So we take a memory location, some space in your memory, we stick a label with the name on it, and we place in this space the piece of information we need to store for future uses. Okay, is it clear? Any question? So x equals 12 is an assignment, meaning that the 12, the integer value 12 is stored in a small piece of memory called x. We may also modify the content of our variable this way. This is another assignment. In the new assignment, a new value is associated to that memory location bearing that name. So if we need to show the this is print is a function for displaying the content of a variable. of course, we replaced the old content with the new one. The old one disappeared, and the new one was stored in its place, and this is how it's displayed. Okay. In my experience, the best way to understand that equality is not equality is this kind of assignment. X equals X plus 1. What's the meaning of this assignment? Take what's on the right and store in the variable in the memory location on the left. Okay? There is no equality. This is an assignment. Carry out the needed computations on the right and place on the left. What's the output? Which is the old value of X? So plus 1. Okay. We have only 1 minute left, so I should stop here. If there are no questions, are there any questions? Okay. Yes.
Do we have the license with the university to use the channel? Because I saw that it's not for free.
No, probably you should download the kind of community edition.
Okay, it's fine. Yeah, that's
It's not. It's a non-commercial one. I need to solve the problem of your attendance. Professor Villari told me that there is some kind of app that you should already know because you use it when working with to book. Please, the lecture is not over. Okay. How did you book your presence? Sorry? Which?
Telegram group, and from there they share to us a link that will bring you to a new email where there are all the steps to follow to attend the lectures included. Just give me a second.
Professor, so you to the point for then need to be here to understand how to do it.
Okay.
Now go a little bit down. More.
The link is maybe go to X.
Okay, here there is a link.
This one?
Yeah.
Professor, you are mute.